then there are other pieces that I'm thinking it would really do you good to have at least one really good one, if not two really good problems to practice. So we were at this one, which is graph each system of constraints, name all the vertices, find the x and y values that maximize and minimize the objective function, and checked with Miss Gosha, because when I got done teaching geometry, I actually gave her all my rulers and compasses and all that good stuff, and she said, you can use a ruler tomorrow. So hopefully, if you do a really good job of graphing them, you'll be able to see, boom, there's my vertex, oh, that's the one I want, and everything will be nice and clear. So this is graph each system of constraints, name all those vertices, then we're actually going to go and find the maximum and the minimum of this. And the first one we see up here is x plus y is less than or equal to 5. There's two different ways to get that boundary line graph. What way would you do it? So the zeros. Yeah. So I was talking about the thumb method, where you look at this as if it's x plus y equals 5. And this one is really fast and easy because it's obviously going to be 0, 5, and 5, 0. And that's a quick way to get it. So we go to 0, 5, and 5, 0. And then we pause, because what do we need to check? What do you check for? Solid or dash? What is this one? Solid. And yeah, if you've got the lid of your calculator to make a nice straight line with today or something along those lines, we will probably be able to see this one if we're kind of careful. Well, it didn't say x plus y equals 5. It said x plus y is less than or equal to 5. So should I shade towards 0, 0, or should I shade away? Yes, because if we test 0, 0, this will say 0 plus 0 is less than or equal to 5. Well, of course it is. 0 is less than or equal to 5, so we'll shade this one. So top one done. Get a different color. And this one is x plus 2y is less than or equal to 8. I don't like where the mouse is sitting right there. There we go. That one the same way. You just solve that one for y. What would you do? Thumb method again? Yeah, most people would do the thumb method. So our zeros, if x is gone, 2 times something needs to be 8. So what's the something? 4. If y is gone because it's 0, what does x have to be? 8, yeah, because it has to say 8 equals 8. So that graph for the boundary line will use 0, 4 and 8, 0. And again, if you have some kind of straight edge, use that, but dashed or solid. Yeah, this is solid, bless you. And usually with the ones we have to go from graphing to finding vertices, they're usually going to be solid anyway, but we should check. It's one of those things when I look at it, I go, oh, they're all equal, so they all have solid lines. Shade it towards 0, 0, or shade it away? Yeah, because it's 0 plus 0 is less than or equal to 8, which of course it is. So shading towards 0, 0 is this side of the line. We'll get to those bottom two. And those bottom two are really to just tell us, stay in the first quadrant. Remember, with word problems, a lot of times whatever it is you're looking for has to be a positive number. So what I usually do is just kind of make the little half box right here to show that I know, yes, it's up there. That's where we have to look. But now you go back and you find your double shading that's just in first quadrant. And that is this region. So now what do we need that for? double shaded between? The vertices, yeah. And this one, hey, that's 0, 0. There's no mistake in that. Abby and Chase, please pay attention. There's our 0, 0. The green one, we just got done graphing. That was our 0, 4. This red one down here, we just got done graphing that one too. That one was 5, 0. So there's only one that I'm kind of iffy on. You know, if I had a ruler, I'd feel a little bit better about it. But it kind of looks like 2, 3. You guys agree on yours? Does it look like it's 2, 3? 3, 2 or 2, 3? Mine's 2, 3. Is yours 3, 2? Well, then this is a good one for us to check on. I say it's 2, 3, and Abby says it's 3, 2. And we have lots of ways to check. Lots of ways. So here's the first way. We take 2 and 3, and we plug it into these two equations, pretending that it says equals. So like this. If it works for both, then it's 2, 3. And that's only going to happen for one solution. So let's try 2, 3. 2 plus 3 equals 5. So far, so good. 2 plus 6 equals 8. Okay, but let's just say you're doing the test. You get 3, 2. Let's check it. 3 plus 2 is 5. You're going, yes, I got it. But you come down here. 3 plus 4 is not 8, and you'll know. So that's a good way to check and see which one it is. Now, there's another way to check and see what it is. Grab your graphing calculators. Remember, your graphing calculators, almost all of them that are in the room, are going to do the shading and everything for us. But what we have to do is get these to say y equals. So my red one up there, I'd have to subtract the x from both sides. My green equation, I'd subtract the x. And then I'd have to divide by 2. So what I need to do is put this into my calculator, but with less than or equal if I can. My calculator up here has that capability, so I could put less than or equal to right there, and then put the green one in, and that one was also less than or equal to. But even if you don't have that app on your calculator, you could still use the calculator to find the intersection of those two lines and be absolutely certain it's a 2, 3. So let's try and use the app for everybody that actually has the app. And it's an application, so we go into apps. And what we're looking for is n equals. And mine takes a long time to scroll down there, so I'm going to cheat and use the I on my calculator to get it pop up. And then we hit enter. And that turns it on for us. So, so now it's giving me the option, instead of equals at these positions, I can use any of these buttons to change it to an inequality, but I have to use the green alpha key first and then see what I want. So if I want less than or equal to, I'm going to have to hit alpha and zoom to change that from equals to less than or equal to. And I want to do that for both of them. And I'll give you a chance to go ahead and punch those in. We have the negative x plus 5, and then we have negative 1/2 x plus 4. Oh, to get these, you have to hit alpha, and then the button is here. So button is alpha is 1. Remember, to get that to change to an inequality, you hit alpha, and then you hit the button that's right underneath which inequality you want. Everybody have them in? Something goofy, Sarah? Yeah. Oh no, we're going to give you something else. Yeah, we're going to give you something nice. That's something very easily checkable. That you can put in there. Yeah, we won't give you a 1/3, -3/7, something like that. That would be horrible. So if you, I don't know if you heard Sarah's question, it was, is it going to be something nice, like this one came out to two nice integers, 2, 3, or is it going to be something difficult? No, we're going to make it come out to something nice, a nice integer. Now, if we hit zoom 6, or even just graph, it's going to do the shading and everything for us. But what we really cared about was, where did those two hit each other? So whether or not the shading is there or not, we're all going to be looking for this spot right here. So that will be second, trace, and number 5, intersection. And if you hit enter 3 times, now we're absolutely certain 2, 3 is it. That's the point that we should have got. Oh my, let's try zoom 6. You're going to go set for a word. There we go. That's better. I hit zoom 6, which is a little point. Yeah, try zoom 6. All right. So now we are absolutely certain about 2, 3. Whether or not you check it algebraically or you check it with your graphing calculator, I don't care. In fact, if you look back now, look at the 2 problems we did just before this one. Do you see how you could totally check those with your graphing calculator if you solve for y? Yeah. For this test, there really shouldn't be anything that you are unsure of as whether or not you have it right or not when you hand in your test. Everything is checkable. Everything. So let's go back and let's finish this one up. Now that we know those are the vertices, what do we do with them? Exactly, and I like that you said bottom equation, because that's what that is. That's not an inequality, that's an equation. That's our objective function. So if we put 0, 0 in here, that'll be 0 plus 0, which is, of course, 0. 0 and 4, well, that'll be 0, and 3 times 4 is 12. 5 and 0, well, that'll be 5 plus 0, which is 5. 2 and 3, well, that'll be 2 plus 9, which is 11. So now we have to tell them the max of something, and I know you have spaces on your test, but I don't want to scroll up because then you might not be able to see what I'm doing here. Max of, what was our biggest number to come out of there? 12. At the ordered pair 0, 4. That was our biggest, but it said max and min. So I hope you can see this down here. Min of, what's the smallest one? 0. At 0, 0. That's how we would fill in those blanks. So something basic like that will be on the test tomorrow. 43210. How's your confidence here about this one? What are you thinking? Pretty good numbers. Some of you are shining a little bit down there, but I think you're going to feel a little bit better if we do, more of this type of thing, especially just even the setting up the word problems. I think you're going to find you know a lot more than you thought you did about word problems at this point. So let's see, is that all that's on your one page there? That's it, huh? All right, off we go. And truly, I do believe the hardest thing about these 2 word problems is just going to be the setup. Once you have the setup, you guys are really good at substitution and elimination, so that's not going to be a problem. And we've talked about the easiest way to set these up, grab a total and use that to figure out how to write this stuff. So it says you've got $5.55 worth of change in your pocket. That's a lot of change in your pocket. You realize you only have dimes and quarters in your pocket. Well, I suppose it could happen, kind of a coincidental thing. You count out 33 coins. How many dimes and quarters do you have? Give me a total. 33 coins. Give me another one. 555. So what we just did was determine how we're going to set up these equations. This was about the number of coins that you have. So everything else that we look up for that equation has to be about the number of coins. So I'm looking for, did they say we need twice as many many dimes as quarters? Do we need 3 times as many quarters as dimes? Did they say anything? So what do we put? X plus y. Dimes plus quarters equals 33. There it is. Well, now the other one was about money. So we're supposed to know something about money that involves dimes. It's worth 10 cents exactly. And we're supposed to know something about money for quarters. What do you know? 25 cents. Oh, I don't have room for my Y in there. Now, we could use elimination. I wouldn't recommend it. You know, if you multiplied everything by negative 0.1 up here, I'm trying to match decimals. That's just no good. So this would definitely be easier if we get the X or the Y by itself. You have a preference? X? All right, let's get X by itself. So X will be negative Y plus 33 or 33 minus Y. Makes no difference. So we've got X by itself. Now what do I have to do with that? That's called substitution. We're going to put it into where? The equation we haven't used yet. Exactly, for X. So this is going to go right here for X. So we're still going to have our 0.10, but now we're going to have to put in negative Y plus 33, or like I said, you can have 33 minus Y, plus 0.25 Y equals 5.55. And yeah, you probably want the calculator handy. Not a lot of people like to multiply by decimals. And since that big calculator on there is so slow, I'll just grab this because I know you guys can do this. So we would have a negative 0.10y plus 3.3 plus 0.25y equals 5.55. Well, then what would you do? Combine like terms. All right, so we've got a negative dime y and a positive quarter y, so that's going to be 0.15y plus 3.3 equals 5.55. Then what would you do? Yeah, take 3.3 away. So 5.55 minus 2. Well, we probably would do that. I don't know. Are you guys punching everything in? Some people may be doing it in their noggin and others punching that in, getting our 225. Then divide. So our 225 divided by 0.15. What you get? 15? 15 what? Yeah, those were the quarters. Remember, I had X stand for dimes and Y for the quarters. So 15 quarters. Did they just ask us how many quarters there were? So we need the dimes too, don't we? Well, the good news is we know they have to add the 33. So if you just take 33 minus 15, you should find how many dimes you need. How many? 18. And there it is. So like I said, I look out, everybody's heads are down. I know you guys can do this part. It's just get the setup. So you know what? I'm going to stop and check right now. How many of you 43210 me on setting this up? Being able to do that part on your own. I think it's a whole word problem thing is why I see the numbers are a little bit lower. Well, then it's a good thing we have another one. We have another one to work through. Again, just think, where is my total and How do I get that total? You're going to sell tickets for a high school concert. Student tickets cost $8 and general admission tickets cost $15. You sell 575 tickets. I can't whistle up. $6,840. That's a lot of money. How many of each type of ticket did you sell? That's now where I'm going to start. Give me a total. 575. Give me another total. 575. The label was tickets. Did they give us any information about the tickets at all? So what do we put? That's exactly what we put. But I think we know some stuff about money. 6,840. What did we see up there about money?
General admission is paid, student is paid, general admission is paid.
Okay, so I'll make x equal the students, and y will equal the general admission. $8 per ticket, $15 per ticket. Are we going to solve this any differently than we did the last one? Of course not. You know, maybe somebody decides to solve for y instead of x, but we're going to solve it the same way. In fact, let me solve for y this time, so that's just a little bit different than the other one. Some of you are probably already halfway through the problem. As long as we get the same answer, it doesn't make any difference. So we'll take this, and we'll put it in for y. Then we distribute, so 8x minus 15x. Race. 15 times 575. 625. Combine like terms. 8x minus 15x is a negative 7x. And then we have plus 86. 5 equals 6840. And then we have to subtract. And this is the reason why I wanted to solve at least one of these for y. Because this is a point where some people convince themselves, oh my gosh, I'm doing something wrong. I'm going to get a negative number. 6840 minus 8625 is negative. It's negative 1,785. And then they start erasing things. But they shouldn't erase. Why not? We're going to divide by a negative anyway, and the answer is going to be positive. So just because you get a negative, don't freak out. It all works out in the end. So I have x equals 255. So that's student tickets. 255 student. And they have to add to 575. So if we take 575 and we subtract our 255, we will get 320 general admission. Now those of you that solved for x first, you ended up getting the 320 first, and then got the 255 and went back. But is everybody getting those two numbers, one way or another? Yeah, so there's lots of ways to get the right answer. You just have to make sure that you go slowly and carefully, and when you're done, you can always check. Make sure this is going to give you the $6,840 it's supposed to give you. So now, that was the second word problem. 43210 me again. I think you were just kind of feeling like the word problems are, a little overwhelming. If, as we go through all of this, you're giving me, well, I would say probably 2s or 1s, you can come in today after school. We can run through the practice test again. If you're not feeling comfortable, come on back in and we'll just go through it again. Alrighty. This looks like a huge problem down here, but it's actually kind of multiple choice. List all the points that are solutions. Okay, to be a solution, it has to be in the double shaded region because there's two lines here. There's one obvious choice, right? What is it? C. It's in the double shaded region. But some of you figured out there's another one over there too. What is it? Yeah, this is on a solid line. So this actually has two correct choices. Why not B? It's dashed. Remember, that's just a boundary line. That's not a solution. So anything on the solid lines work, and anything in that double shaded region work. So I don't even want a 4, 3, 2, 1, 0. You gonna do well on that tomorrow? All right. Now this last one is scary. So this looks awful, right? Okay. A city wants to plant maple and spruce trees to absorb carbon dioxide. It has $3,600 to spend on planting those spruce and maple trees. The city has 86,000 square feet available for planting. Use the information in the chart. How many of each type of tree should the city plant to maximize carbon dioxide absorption? What is the objective function? What are the constraints? Hang on a second. So where's the spot where we write down the max and the min? We don't have to do that on the test. On the test, all we have to do is set up the objective function and the constraints. Because this would be murder to graph. Look at the size of the numbers on this thing, 86,000 square feet. We'd have to use algebra to figure out where the rest of the intersections are. So with this one, we are just going to set this up. All right. Alrighty. So first things first, objective function. What is it that they are trying to do? Read through the problem. What did they want to maximize or minimize here? Carbon dioxide absorption. So that means I'm going to use a C for carbon dioxide, and I'm going to go in the table and I'm going to look for something about carbon dioxide absorption. Well, there it is, right there. So now all we have to do is decide if we want to use S for spruce, which is a bad idea. So we'll go ahead and use X for spruce and Y for maple. So C equals what? That has to do with carbon dioxide absorption. That's it, 750x plus 600y. Objective function, there it is. Now, what are the constraints? Well, obviously they didn't have an endless supply of money. Yes, they don't want to spend $3,601. They're saying $3,600 is okay, but nothing else. Now, here's a tip. We already used this. Scratch that off. You don't want to accidentally use that again. That was for the objective function. That was not for the constraints. Now, I think there's some pretty obvious stuff about money in that table. So what do you think we're going to do with that? No dollar symbols. You never put symbols in inequalities or equations. It's just 70x plus 80y. Was that the only thing holding them back? What was the other thing? Yeah, I know we say only 86,000 square feet, but yeah, it's only going to take so many trees. 86,000 square feet. Now, I used that one. Yeah, it really is that easy. Does everybody see that? This says area required. That's what that's about. So 600x plus 800y less than or equal to 86,000. And we would get almost all the points if we stop there. Can you have a negative amount of spruce trees? Can you have a negative amount of maple trees? We need to put x is greater than or equal to 0 and y is greater than or equal to 0. That's kind of the common sense step. You know, when you say, these are trees, we have to have 0 or positive values for that. And like I said, You don't have to do anything else with this. Nothing. Just setting those up. So if you see a table like this on the test tomorrow, 43210, how do you think you're going to do on that one? Pull this off. All right. Looking good. So now what I'm going to do is, the people that were gone. I already got you the little slip, didn't I? Did anybody else use their little assignment slip? Well, then I'm going to trim that down for you a little bit anyway. Let me see if I can get notebook up here. And I'm not trimming it down a lot, but the problems that I'm taking out were problems that are probably going to take you a while, so that'll help time-wise. Come on, notebook. Give me a screen. Just open. There we go. Alrighty, so the first line that you hopefully already did was page 146, number 31 and 41. The middle one, remember I said just set it up. So that's writing those inequalities, but you don't have to find all of it for me. And here's where we're going to make some cuts. Pages 183 to 185. We're going to do 1 through 15. 17, 19, 20, and 22, but I'm going to take a big chunk of work off there. For 19 and 22, just write the constraints and the objective function. Again, just set it up like we did on page 160, number 13. So I thought, well, we need practice, but I don't want to make it so much practice that it's going to kill you before you take the test. You know? So we've got at least one of every kind of problem you're going to see on the test. And that should be enough. Because you guys are most overwhelmingly, the class is doing really well on this. When I check the numbers, things are looking really, really good. And we know we can check our answers. So if you need to, spare books over there on the side, but get rolling on this. What do we have to today? Oh, 113. You could probably almost finish this before you get out of here, especially if you started yesterday, which some of you already did.